Okay guys, so this week is going to be one of the more applicable weeks and really in my opinion, the funnest week of summer. I really think this stuff is pretty cool because it's one of the first times in your math career that you get to do some real world stuff. And so the title here says it's a scatter plot. And scatter plot is sort of the term that's used for any type of data that's been taken, and maybe the points are the data points are scattered all over the board, okay? And what you're trying to do is take a look at the trend in your scatter and see what kind of trend that the situation has. And we'll talk more about real world situations in a second, but let's just talk about analyzing points. So I'm going to write over here, I'm going to write for the say what, that we are trying to, where is my pen? Hold on just a second. Okay, so on the say what, I'm going to write that we are analyzing the pattern. And that's pretty much what we're going to be doing this whole lesson, just analyzing the pattern that we see. So over here it says examine the trend in your coordinates, okay? And I'm going to use different colors for this. And I don't know how you guys might want to do it because we're going to have dots all over the place. And if you have markers, I would get them out now, or matte pencils, or if you don't, we can draw different shapes maybe to help. But I want to show you the difference between these four things, okay? So let's suppose that we've taken a bunch of data points, and I'm going to draw these as just circles, and we have I'm just drawing some random circles. But notice that my random circles, if we had to analyze the pattern, it looks like it's going up. And if the pattern looks like, even though it's not a complete straight line, if it looks like, oh, well, all these points are kind of headed up in this direction, that is what we call a positive correlation. So this would be like where the points appear to be increasing, okay? Now, a negative correlation, you might guess it, is going to be the exact opposite of this one. So I'm going to do this in blue, and I'm going to put points appear to be, what would be the opposite? Decreasing. Points appear to be decreasing. Okay, and so to draw a few dots that do that, we're just going to make a few random points. I'm not going to make them in a line. I'm just going to kind of draw a few random points. There we go, and they all appear to be going down. Now, if you're taking notes on this and you want to be specific at home, you do not have to do points exactly where I did points. Just draw your own set of points that look like they're going down. And notice when I talk about increasing and decreasing, I am looking at the picture left to right, just like a book. So I'm going to put read your data points from the left to right. And if you just keep in mind that it is always like reading a book, then you can see I'm reading a book, they go down, the red ones are going up, okay? Now a constant correlation, let me switch to green. Constant correlation would mean that they're not moving up or down. Instead, maybe they're moving like straight across the page. So maybe you see like something like this going on, where you feel like they're all grouped around a line, and it's just cruising steadily in like this horizontal line fashion. Okay, so they're not up, they're not down, they're just cruising straight across. So this would form a horizontal line. And remember, the word horizontal does mean side to side. Okay? All right, cool. And then no correlation. Now, no correlation is sometimes hard to figure out. It really is. No correlation. I'm going to switch to black for this. There appears to be no pattern or no trend. And a lot of people try to look at points and go, oh, I don't see a pattern. But guys, really try to discover, are they going up, are they going down, are they straight across? So a no correlation picture would actually be like all of these dots combined. And I'll go ahead and draw new ones. But, you know, if you see points that are just all over the place, you know, here's one here, 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 but then we come back down and then we're across and then we're here. I mean, you never know. But if there is no rhyme or reason at all and you can't find a pattern, that's when you should say that there's no correlation, okay? So correlation, just fancy talk for the pattern, okay? So positive pattern, negative pattern, constant pattern, that's pretty much it, okay? So now that we've talked about the vocab and how you're supposed to sort of look at your stuff, let's actually try a problem and see what the point of all this is, okay? And then we'll go into the real world stuff that I mentioned. Okay, creating your own scatter plot and using it to predict. So the first thing is it says plot the following points, and it gives you a bunch of points on the grid. Now, notice I did not draw the entire like quadrants 1, 2, 3, and 4. I didn't, because all of these, if you look at these points, everybody's positive. And if everybody's positive, what quadrant are you in? Well, you're over here in the first quadrant, okay? This is your x-axis, this is your y-axis, and everybody's positive if you stay in this upper right section. That's why I didn't draw the rest of the coordinate plane. But let's plot the points. So the points are x comma y, and so we need to go over 1 on the x and then up 0 on the y. So there'd be a big fat point right here. 2, 3, I need to go over 2 and then up 3. 3, 2, over 3, up 2. 4, 7, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 5, 4, 1, 2, 3, 4, 5, and then up 4, 1, 2, 3, 4. If you're faster than me, great. If you're slower than me, that's expected because I've done this a lot longer than you. 1, 2, 3, 4, 5, 6, and then up 6. 1, 2, 3, 4, 5, 6. Okay, cool. So this is my my scatter plot. Okay, so all the points together form this scatter plot. They're not in a perfect straight line. They're kind of all over the place. But what we can do is we can look at the trend in this data and we can talk through a few things. First of all, based on what we did above, what kind of correlation do you think this is going to have, you know? And this is what this question says here. What type of correlation is this going to have? Do these appear to be going up or down or staying constant, or do you see no pattern at all? Well, hopefully you notice as you read it left to right that they do kind of go up, which means that the answer to correlation is positive. Okay, that would be the word that we use to describe correlation. And what you're able to do is once you notice that things are going up, you are able to sketch what's called a line of best fit. Line of best fit through your data. Some teachers call it a trend line. I'll write that above it because I don't know what your teacher's going to say. They usually say line of best fit. But who knows? Okay, so a trend line or a line of best fit. Now, this just means that when you look at all these points, if you had to draw a line through the data, what would be a good line that goes through all of these points? And it's not going to go through all of the points, but you want it to look like it's a good representation of the points. So for me, I would probably go in between all of these. Like I'd probably start here, and I would kind of draw a line that just goes up through everybody. So this will be tricky because it's hard to draw a straight line sometimes. But mine would probably look like this. Whee! Okay, so notice my red line goes through all the points. And by through it didn't intersect them, but it went in between them, okay? And now that we've done this, we can use our line to make predictions, okay? So the first thing is before we make a prediction, right here it says find the blank of the line. Now you don't know what I'm going to ask for here. I'm going to ask for something called the slope of the line. Now if you haven't done slope before, slope is a measure of steepness. So we're going to measure the steepness. It's also called the average rate of change. of the line. You are going to be asked to find the average rate of change a whole lot over the next couple of years, okay? And when you see average rate of change, that's just the slope. And the way that you measure slope is you find 2 good points on your line. So I've already got one chilling out right down here. And then I need to find another good place where my red line intersects my grid. And so, you know, if you look right here, this is not a good corner, but look for a good corner where it intersects the grid. Okay, how about right here? Do y'all see how the red line looks like it's crossing the grid at the exact point right here? Okay, once you find 2 good points in a row, you just need to count on your y and x axis how much this thing has risen. So from this point to this point, it would go up 1, 2, 3, and then how many I've gone over. So I've gone over 1, 2. So that amount that you rise and then the amount that you go over, that is your slope. So it's how much your y's have changed. I'm going to write change of y over the change of x. This measurement, written as a fraction, is your rate of change. And I know that's a little confusing, but after we do another one, I think it'll make better sense. So how much did my y's change? Well, they go up by 3. How much did I go over on my x-axis? I went over 2. So it's kind of like your up and over. Or another way to think about it is your rise over your run. All of this stuff means the same thing. All of it. Slope is your steepness. It's your average rate of change. It's your change of y over change of x. It's your how many up, how many over, and it's your rise over run. They're all synonymous, okay? So however you need to think about it is up to you. But that's what it would be. This number, this fraction, would be our answer. And what's nice about that is that if you drew a terrible straight line, like maybe you're bad at straight lines, you can keep counting up and over all the way across, and you can have a really good straight line. So like if I just went up 3 over 2, then from this point I can go up 3 over 2, and that's where I should have crossed my red line, up 3 over 2. So you can see at the very end my red line was starting to get a little crooked, so I can kind of go back over and fix that now. There we go. And then from here I could also go up 3 over 2. Now I realize that that's off the grid, but you could at least do this to keep your line going a little bit. Now why would you want to keep your line going? Well, read right here. Use your line to predict the y value when the x value is 10. Well, my red line totally went off the grid, right? Like if you go over to 10 and you look up, we were out of space. But if I kept that red line going, then we could make some kind of a prediction, okay? So when I go over 10 and I go up, it looks like I would have to go up about 11, maybe 13. I'm going to put 13-ish because we can't really see it, but we're just making a prediction, so it's 13-ish. If your teacher doesn't like that kind of poor English, then maybe you could write about 13. Close to 13, something like that. Okay, so now that we've done this, we get to do a real-world example. Yay! Okay, so with a word problem, as you read, you want to sort of label your x and y axis so that you understand the problem and what's going on. So this is x and this is y. Now, in this first sentence, we just went on a road trip and we've been checking the clock every hour to see how much further it is to our destination. So it says, let the x-axis represent hours that have passed. So down here, I'm going to write hours passed, so these are hours that have gone by, and the y-axis represent how many miles away we are, okay? So I'm going to put miles away. I'm just literally writing what it told me to write, okay? And then it says in hundreds of miles. So what that means is this 1 would really be like a 100, that would be a 200, 300, 400, so kind of keep that in mind, okay? All right, down here. when we jump in the car, our destination is 850 miles away. This is my first data point, okay? And here's why. When we jump in the car, how much time has gone by, guys? No time has gone by. So I'm right here at 0, and I'm 850 miles away. So my first data point is way up here on the y-axis, okay? After the first hour, so when 1 hour has passed, we still have 800 miles remaining. So after the first hour, we have 800 miles left. After hour 3, so after hour 3, 1, 2, 3, there are 625 miles remaining. So at this 3-hour mark, we need to go up to 625. And actually, I wonder if I should do, let's see, after hour 3. No, that's fine. Okay. 625 would be, maybe, I don't know, just right above 6, just kind of like right there. We take a nap and then measure again at the 6-hour mark. Okay, so at 6 hours, we have 410 miles to go. So 410. Okay, cool. So it says the goal here is after how many hours will we get to our destination? Well, these look like they're in a pretty decent straight line. It's not going to be an exact straight line, and that's what makes it a scatter plot, but it's close enough that we can tell this line's going down. So it has a negative correlation, and I can draw my own line of best fit to try to figure out, how many hours it's going to take to get there. So I'm going to start drawing a line through these, and my line's probably going to be, okay, that looks like my line. And let me just try to find a couple of really good points that it crosses at. Like for instance, I made it go through this one, and that's at a good corner. And another good corner that it goes through looks to be this one right here. So remember, you're looking for where it crosses the grid really well on the X and Y axis. And it's going to be hard, it's going to take practice, but I definitely look like I crossed these 4 and these 4. So now let me make sure my line's actually straight, okay? So I went down 1, 2, 3, and over 1, 2, 3, 4. So I went down 3 over 4. So let me keep doing that all the way across. Down 3, 1, 2, 3, over 4, 1, 2, 3, 4. Awesome, I did a good straight line. Down 3, 1, 2, 3, over 4, 1, 2, 3, 4. So if I kept my line going, it would look like that. Now, what is the goal here? It's like, how long will it take to get there? Well, guys, getting there means we need to hit 0. We need to hit the bottom. And I realize that we're out of room, but if you just kind of keep this x-axis going over to the side, this is the 0 hour, sorry, 0 mile mark. This is 0 miles, and so I need to know when my blue line hits that. So if I can find that spot on my graph, I'm in business. And if you just kind of look at your scale, this is 9, this is 10, this would be 11. This looks like 12. It looks like 12 hours. And it looks like it crosses it pretty well. If you thought that it was a little off, you could do like 11 hours and 50 minutes or 12 hours and 15 minutes. You can approximate here. This is an approximation. Until you get to Algebra 1, people, you're approximating, and that's perfectly fine. Okay, so that's how you can do a scatter plot and actually relate it to something and make a prediction. So some serious real world stuff going on. Oh, and I left out one thing. What was our average speed during the trip? My bad. Sorry, I just saw that. Okay. Remember average, an average of something, and I say remember, but you know how I gave you all those words that mean the same thing? Okay, so this is also like rate of change, which is the slope. So when I was drawing my graph, do you remember what I was doing? I think I was going down 3 and over 4. Okay, so the 3 and the 4, these are our answers, but we just have to put words behind it so that it actually makes sense. So how do I do that? Okay, so for every 3, and this was on the y-axis, and so that was measured in hundreds. So for every 300 miles, it was taking how long? It was taking 4 hours. Now, how did I get miles and hours? I just looked at the axis, guys. This was what I was doing on the y-axis. This is what I was doing on the x-axis. And so if you look at how those are labeled, then you're going to understand how to label these numbers of 3 and 4. And remember, it was 300 because this was measured in hundreds. So this is kind of a higher level deal. I hope I'm not blowing too many minds here. And if I am, we'll talk about it in tutorials or shoot me an email. This is like the pre-AP version, so don't panic on me, okay? All right, so what do I do with this number? Well, I would probably just reduce it if I could. Does 4 go into 300? I think it does. Yeah, it does. Okay, 4 goes into 30 7 times. Okay, so 75 miles per hour. That's how fast we were going. So if you just reduce 300 divided by 4, you get, this is how fast we must have been averaging on our trip. So we were booking it, but we made some good time. This is pretty much a drive, if you want to kind of imagine this in real world. At this speed, with this data, this would almost be like going from here to, you know, part of Colorado, or to part of Georgia or Alabama, something like that. That's about how far we're driving here, and that's how fast we're going. All right, good luck trying your problems. One of them, you have to collect data, and so don't put it off till the very last minute. Read it. It's kind of interesting. You could call a few relatives or call a few friends, and you could make your own scatter plot. And a lot of our information is going to be different, but that's okay. I want to see what you guys are doing. So maybe even email me back when you collect your data, just so I can see what everybody found out from their survey and their scatter plot.